We have a simple circuit as shown in the picture. It's basically a battery connected to a resistor, and there's a voltmeter measuring the voltage across the battery. There's also an ammeter connected in series together with the resistor. Right now the switch is open, so there's no current passing through our circuit. We also see that our battery has some internal resistance. Now, as the switch is open, the reading of the voltmeter is 3.50 volts. Next, we close the switch, like so. Now the reading of the voltmeter drops to 3.42 volts, and now there's current passing through our circuit, and the ammeter is reading 1.25 amps. The first question is, what is the EMF of the battery? Now, the EMF of the battery will be the reading of the voltmeter when there's no current passing through the battery. So that's basically equal to 3.50 volts, what we were reading before we closed the switch. Therefore, the EMF of our battery is equal to 3.50 volts. The next question is, what is the internal resistance of the battery? Now, for that, we're going to use the reading of the voltmeter after the switch was closed and the current passing through the circuit now. The reading of the voltmeter after the switch is closed is going to be equal to the EMF minus the potential difference across the internal resistance of the battery. So let's put that in an equation. Here's our equation. Voltage across the battery is equal to its EMF minus the potential difference across the terminals of the internal resistance. So for the internal resistance, I'm using lowercase r. Let's isolate lowercase r internal resistance and calculate. And here's what we get after the calculation. The internal resistance of the battery is equal to 0.064 ohms. In the last step, we'd like to calculate the resistance of the resistor in the circuit. For that, we can use Ohm's law. So there's only one resistor in the circuit. The voltage across the terminals of our resistor is going to be equal to the voltage across the terminals of the battery. So let's just go ahead and apply Ohm's law to this resistor and calculate its resistance. And here's what we get when we apply Ohm's law to the resistor. Resistance is equal to voltage divided by current, and the numerical value is 2.74 ohms. Now note that we're able to do this because the existence of the voltmeter and the ammeter really have no effect on our circuit. The voltmeter has infinite resistance ideally, so there's no current passing through it, and the ammeter has zero resistance, so it does not have the potential difference across the terminals of the ammeter is practically zero. That's why the potential difference across the terminals of the resistor is equal to the potential difference of the battery, which is the reading of the voltmeter when the switch is closed.